video hear me?
Yes, the video can hear you.
You should post Get Ready With Me for school.
I don't think anyone's interested in that. But okay, so graphing using y-intercept method, you're gonna see this section of the lesson is like super quick because this is just grade 9 stuff, right? We said yesterday we were doing like the table of values where we had to do like the input and the output. And it just took so long having to make that table of values. It's not sustainable. It's too time consuming. So this is the easier method. Knowing your like initial value or your y-intercept and then doing your slope or your rise over run. Super fast. So like for example, with this one where we've got, okay, y is equal to 1/2 x minus 2. I gotta think, which one's my m and which one's my b? If I'm thinking about y equals mx plus b. Which this one, the one that has my x attached, that's gonna be my m. This you can also think about as rise over run. Right, so that means I'm going up 1 and over 2. Up 1, over 2. Right, and then this is my b. This is my initial point or my y-intercept.
I subscribe.
Thank you. Right? So all I'm gonna do in pink, which I'll make this color, will be, okay, I have to start at -2. So I'm always gonna start on the vertical line. I'm not going to -2 on the horizontal, only the vertical. And then I'm gonna count. I'm going up 1, over 2. So there's gonna be my next point. And I'm gonna repeat. Over 1, or sorry, up 1, over 2. And same thing. I ran out of space this way. So we're gonna go down 1 over 2 to go backwards. And you can see, oh, that's more than enough for me to connect and draw a line. It's okay. There's my line in pink. Right? Was that okay? Just drawing that line quick like that, right? Didn't have to make a table of values. I can kind of see what the coordinate points are gonna be based on this pattern.
Negative.
Same,
What's the negative have to do with it?
what negative? The -2?
No, the next question, like B.
This one? So, okay, again, which one's my slope? Which one's my m?
-3.
M equals -3 over 4, which if I'm thinking about this in terms of rise over run, which is slope, negative just means you're going down 3 and over 4. So negative is telling you like direction, for example. And then this 3, that's my b. So that's my y-intercept or my starting point. So again, I'm gonna start at my 3 on the vertical. And then I'm going down 3, but am I gonna go to the left or am I gonna go to the right?
Right.
I'm gonna go to the right. Why the right?
Wait, never mind.
No, why?
It's positive
That's true. And also because we're decreasing. This is a decreasing line, right? So if I go over 4, so 1, 2, 3, and then 1, 2, 3, 4, you'll see, oh, I end up where this pink dot is. And then I don't really have the space to do any more, right? I can't go up 3 and over 4 because I'll be off the graph. So I'm just gonna connect these 2 points and extend. Ooh, that was terrible. There we go. So we went down 3 and then over 4. Right? Where are they intersecting? Where do they cross over each other? We can see it visually. Where is that? At 4, but how would we say it as like a coordinate point, for example?
Oh, Y0.
If we state POIs like this, which POI stands for point of intersection, how would I state that? What's my X and what's my Y?
0, 4.
4, 0. Right, because I'm at X equals 4, and then I haven't gone up or down, so that's why Y is 0. Voila. And that's it. Graphically, we've done it, right? Same thing with C and D. Again, you tell me, what's my M here? Which one's my M? Yeah, what does that just even mean? M is what? What like coefficient is X? It's just a 1, right? If we don't see a number in front, we can assume that it's just 1. Whenever we have whole numbers, we're just gonna put it over 1 automatically. So if it's 2, it'll be 2 over 1. If it's 10, it's 10 over 1. Even if it's a negative number, -5, we're gonna just put it over 1. So then when I go to do rise over run, it's the same thing. This just means I'm going up 1 over 1, up 1 over 1. So that's not changing. And then my b is at -4. So that's going to be my y-intercept. It's okay. Again, I'm going to go to my starting point at -4. So 1, 2, 3, 4. And then this is an increasing line. It's positive. So I know I'm going to be going this way. So I'm going up 1 over 1. And there's my next point. And same thing, up 1 over 1. And you'll see it's just making a diagonal. And that's more than enough for me to connect and draw my line. Okay. Does anyone want to draw the second line?
I don't know.
No? What do we think back there? What do we think?
What do I think?
Mm-hmm.
I think I don't know.
Mm-hmm. It would help if you talked less, right? So, okay, the second line,
Ooh, I have a question.
yeah?
Do you do -2 over 1?
Mm-hmm. You do -2 over 1. So, okay, I'll start with that. Jack's like, okay, this is my m. So, -2 over 1, which this is my rise and run. So, it just means I'm going down 2 over 1, down 2 over 1. But what about my b? Do I have like a plus or minus anything at the end?
It's just a 1.
Is it just a 1?
It's nothing.
It's just nothing. If we don't have like anything here, it's like you're saying +0. So this is your b. So your y-intercept is at 0. We just say nothing, right? So it's going to be starting here at 0. Right? And then we're going down 2 over 1. And again, because I'm decreased, I'm going to the right because I want to decrease. Remember how the other day I said if it's like a negative line, then you use the n, this direction, to show like negative. That's like another way of remembering, so you don't accidentally do it the other way. So it's the same thing, down 2 over 1, down 2 over 1, and then I can go the opposite way to extend the pattern. And I can draw and connect. Whee. Which this one, it's a little harder to see where exactly they're intersecting. It looks a little off. It's not like a clean, perfect point. It's gonna be a decimal, right? So in this one, we can estimate. It looks like it's maybe at about like close to like maybe like 1.3, if I had to call that like 1.3. And then maybe down here, that's maybe like -2.5, if you want to call it. So that's like our rough estimate that we're going to say it's there. But we're going to learn like how to actually algebraically prove exactly where that's going to be. So for now, it's like a rough estimate. How we feel with graphing lines in this format.
Good.
There we go. Okay. Is there any questions about anything like this? I'm okay to flip. Okay. You're going to see. In order to graph a line like that and do it super quickly, it has to be in y equals mx plus b form. Because in this form, as you can see, I have no clue what the slope is. I do not know what the y-intercept is. It's all jumbled up. So in order to graph those lines quickly, you have to have it in that format. So the goal is always put y by itself. It doesn't matter what side y is on, but just y has to be by itself. So, okay. For example, here, how would I put y by itself? What could I like move to put y by itself? You could move the 3, yeah, but then that would join it. I would move 4x for sure. So let's kick this over. And this is going to be minus 4x. So now I've got y equals -4x plus 3. Done. Y is by itself now. So I can see that this is going to be my slope. And this is going to be my y-intercept. Right, so always mx plus b form. What about b? How am I going to get y by itself? What's the first thing that like I can do or move?
+4.
Okay, so you're saying move the y. Okay, I like that. So x minus 8 stays, but 4y is going to move to the other side. So this is going to become plus 4y. Remember I said it doesn't matter what side y is on. We just want the goal to be like y is by itself. Which, okay, I've got y by itself now, but I've got 4y. I just want y. I gotta divide by 4. Whatever's attached to this variable, I gotta divide both sides by it. And I'm just dividing everything by 4. It's okay. This will cancel out. And now my last step is I have to take like each term and divide it by 4, which x over 4, that's just like saying like 1 over 4. I can't simplify that any further. It's not a nice number, so I'm just gonna leave it as 1 over 4 and x. And then 8 divided by 4 though, that's nice. I can do that. That's just gonna leave me with 2. So we, minus 2. And that's gonna be exactly, Jack, your b term, or your y-intercept, I'll say. And we can see, okay, this fraction here, that's gonna be my slope. Okay. You tell me, what about the last one? Do you wanna try it, and then you tell me what you get? Okay, try it, take like the next 2 minutes, see what you get. The same goal, doesn't matter which side you keep. I would say even y is already on one side, keep it there. Yeah, Stone.
You're just writing the coordinate. What do you write for x and y?
For x and y?
You're just writing the coordinate.
Excuse the interruption. At this time, we are asking that our grade 11 classes please make their way down to the auditorium for the course selection assembly. So grade 11 classes to head to the course selection assembly. And of course, if there are any grade 11s and grade 10 or 12 classes, you may make your way to the auditorium as well. Please
I
leave
don't
your
think we have any grade
backpacks
11s.
and devices in the classroom as you will return after the course selection fair in the gym. Please make your way down now. Thank you.
Aren't you here tomorrow?
I don't, there's 2 grade 10 sessions. So if you're not here for tomorrow, then there's one on Thursday. There's another grade 10, because they do the switching. So there's 2 grade 10s. This is just their only grade 11 one. Yeah. Okay, what did we get?
Oh, y equals 5 over 2, x equals 5.
Okay, let's try it. So, okay, what did you do first, Jack?
I moved over the 5x.
Okay, so we're moving it over, which means I gotta change its sign. Okay, and now what else?
And then I got 2y, and then divided by 2.
Okay, we gotta divide by 2 to get y. Which I'm gonna just close the door before that gets super loud. Okay, so we divide by 2, okay, which this cancels out. And then negative 5 over 2, that I can't simplify, so I gotta just leave it,
Yeah.
right? If you want, you can change it to a decimal. It's a nice decimal. It's just negative 2.5, or leave it as a fraction.
I kept it as a fraction.
Yeah. And then we've got x and 5.
And then
Perfect.
the negative 5 over 2 is my slope.
Mm-hmm.
The other one's y-intercept.
Perfect. Amazing. Okay.
It's
Right.
easier when you do it on a graph to have it as the
I like to.
Exactly. Because if you're in standard form or general form, which is like what's up there, or just jumbled up, right? You can't tell what the slope is. You can't tell what your starting point is. So it's getting really hard to graph, right? So being in y equals mx plus b mode makes it just so much clearer, right? Especially when you want to then graph and find points of intersection, right? So even for like these two, for example, look, I've got everything on this side, which I'll do in pink here to denote this one. So it's like, I gotta go about rearranging this because this does not tell me any information. I gotta rearrange. So I gotta put y by itself first. So what do you wanna move? What do you wanna put where?
Move 3y.
You wanna move the 3y? I like that. Keep everything else over and just move one term. So, okay. I'm gonna move this over, which means I have to change its sign. So this is gonna be plus 3y. So I'm gonna be left with 6x minus 15 equals 3y. Okay, I'm close. I still have the 3 attached to it, so we gotta do what? Divide, exactly. Which, lucky for us, these are all like pretty terms. These are all divisible by 3, right? 6 divided by 3, that's gonna give me 2x. 15 divided by 3, that's just 5. It's okay, we've got a nice line, right? And what's my slope? What's my y-intercept?
Never mind.
Slope is 2x.
Mm-hmm. And then y-intercept? -5, you got it. Okay, cool. Now we can graph it, which I'm gonna do in pink, just to denote it. And again, I'm gonna start at my starting point, so 1, 2, 3, 4, 5.
And then just go
Do
up
people
to
got
every
questions
time.
that they wanna clarify? Cause I'm hearing little chats, yeah?
Do you go up to every time then? Because there's
Yeah.
no.
James, why are you sitting there? Yeah. I think that's Eamon's spot.
It is Eamon's spot.
I think that's Eamon's spot. Yeah.
It's like me
So?
just sitting next to.
Because right now we're having conversation instead of listening, right? Same thing at the back. I can hear you talking from all the way up here, right? So that gets distracting, especially for other people who are trying to listen and follow along. So maybe you go ahead, but other people don't. Right? So, okay. I'm at my starting point, and we said we're going, what's our rise and our run? You tell me. How much am I going up by and how much am I going over by?
-5/1.
That's our starting point. What's our slope? You told me the slope.
Negative.
Oh, it's 2x. Oh,
Two.
so it's 2x over 1.
2 over 1. So it means I'm going up 2, and then up 2, and then over 1. And then same thing. Up 2, over 1. Up 2, over 1. And you're just going to keep repeating for as long as you can until you run out of graph space. And you'll see that's more than enough for me to connect. And I'm just going to erase my stuff there. And I'm just repeating with the second line, which it looks like it's almost rearranged to y = mx plus b mode. It's really close. I would look at this and personally be like, what if I just like switch places with like the -6 and the -3y, just so that I can have like y on the other side and have everything else on the other side. You could also just move the x. It's up to you. But
Move the x.
okay, so then let's move the x. So, okay, let's say we're gonna minus x. So we've got -6 minus x, and now that's just -3y. Last step is dividing, right? We can't have this coefficient in front, so everything's gotta divide by -3 to cancel it out. Which, okay, -6 divided by -3, those are divisible. The negatives are gonna cancel out, because negative divided by negative is a positive. So that's just gonna leave me with 2. Right? The second one, though, where I've got -x over -3. I know the negatives are gonna cancel out, so it should leave me with a positive term. I'm gonna have a plus, but like 1/3, that doesn't like simplify to anything nice. It's not a whole number, so I'm just gonna leave it
Sweet.
as 1/3x.
Get that.
And voila, you've got that. Where again, this is your starting point, this is your b, or your y-intercept, and then whatever is attached to x, whatever has the x variable, that's your slope. Which, because it's a fraction, this is a little easier to see rise over run, right? Your top numbers rise, bottom numbers run. Wow.
You go up 1, right 3.
Up 1, right 3, yeah, exactly. Starting at 2.
3/1, that's why I got wrong.
There you go. So up 1, since your rise is 1, and then you're gonna go to the right 3. And then same thing, up 1, and then over to the right 3. So we'll start here. And then once you reach that side, you can just go backwards for the pattern to extend it. And then that's more than enough for us to connect. Voila, right, the iPad almost got it perfectly. And you've got it. Okay. See how much easier that is than having to make your table of values,
I don't even know
plot a
what
bunch
shows
of
that.
points in. I'm never gonna ask you to make a table because it's just too like lengthy. It's too much time. I don't want you to waste time doing that. This is the ideal way, Rylan. Thank you. This is the ideal way to graph a line, right? So I just want to start this one, and so instead of doing the textbook homework, because you'll see this one like looks longer where there's lots of examples to try, I'll say just finish 1.1 as like homework, okay? I won't do textbook homework since we're gonna miss tomorrow's class. What's more important? Yeah, what's with multiple choice? And Jack, why are you on your phone? Can we put it in our bag? Away. Cool. If you want to learn this on your own, you could, but I don't recommend it, right? Because this is like going to speed up and this is a lot of new things and it's easy to make mistakes. So that's why I'm like, just give me the time for like the 15, 20 minutes that it takes to go through it. And then the time is yours to work on it. Especially since I'm saying, no, of course I'm going to do the first one. I'm going to go through a couple of examples with you first, just so that you can get the gist. And then you see there's just a lot of repetitive practice problems.
So many.
Friends. That's why I'm saying I'm not gonna check this textbook homework. If you'd like to do it, I'll make it optional. But because we're trying to like stack a lesson since we're losing tomorrow, just finish the packet. So I'm gonna go through a couple with you, not the packet, but like the lesson for 1.1. So I'm gonna do like the first couple ones with you, and then you can use the rest of class time to just finish it. But it's really repetitive. You're just finding points of intersection over and over again using this graphing method. So like, for example, which is when you talk about solving a system, because I think that's a new term. Solving a system involves finding the point of intersection. That's what it's asking you. So if a question is asking you to solve a system, it's asking, where are these lines intersecting? At what point do they cross? What coordinate point? And a system just means you've got two lines on the same graph, which is new to grade 10. In grade 9, you didn't do multiple lines on, in grade 9, you didn't do multiple lines on one graph. You just did one line per graph. Now you have ones that are intersecting. So, okay, if I wanted to solve this system, where like this is 1 and this is 2, my goal should be always, are they in y equals mx plus b form? Which in this case they are, nicely. So that's perfect. It's ready to graph. If they were not in y equals mx plus b form, I would put them into that because that would help us graph it. And now I'm just gonna graph. So, okay, I'll do this first one in pink and then I'll do the second one in blue. So, okay, my first one. Where's my starting point at? What's my b value for the first one, the pink one? -1, so I'm gonna go all the way to -1 here. And then my slope, what's my rise and my run? 1/1. Why, Rylan, is it 1/1?
Because x equals 1 and then whole numbers to the 1 below.
Exactly, you got it. So I'm going over 1, up 1, over 1, up 1. And you'll see it just keeps repeating and you're just going in a diagonal line essentially.
I got it.
You got it?
Look, I got the answer.
Okay. Hold on to it tight. Let's see. Okay, so that one, pink one, is done. Then I just go to the blue one, what's my starting point for the blue one? 2, okay. And then what's my rise and my run? Because I have a negative in front. So what does that mean? You go down. And Emma, what were you gonna say?
Yeah.
Down 1, and then you're gonna go still to the right,
But you also.
or you're going down. Or if you wanna go up, you would be going like to the left, like that. But if you go then the other way, you would be going to the right and to the right this way. Voila. And you'll see they do cross, and they cross at a nice point. Right? When you want to say a coordinate point that they intersect at, you're going to put the x value first and then the y value. Right? So what would be its point of intersection here? If the x is first, then the y, yeah, Elisa?
Oh, isn't like the rise to -1?
Wait, wouldn't it be -1/2?
You're right.
Oh, Dick, I was right. I was like,
You're right. Well, okay, that line would cause that intersection. Okay, so we said starting point was 2, but we go down 1 over 2.
oh yeah.
See how quick? Even math teachers are susceptible to this human error. Okay, this new connection. Another pretty point, which now what is the point of intersection? That looks to me like, yeah, at 2 and then at 1. Voila. Perfect. So see, if I had flipped it, so that would have been what? That would have been going down 2 over 1. So that would have been like -2x plus 2. Then that point of intersection would have been over there with that line. So it would have changed it. Perfect. But that is your solution to the system. So if it asked you point of intersection, what's your solution? It's just the coordinate point. It's not like a specific value of x equals or y equals, right? You can verify your answer algebraically, which sometimes, friends, this is good to do, especially when you've got ugly numbers, because you will see some ugly numbers. So if we want to verify, is 2, 1 really the point of intersection? Like, are we super sure that that is the point?
Yeah.
We're going to plug it in, and we're going to see, does left side equal right side for both of our equations? Okay, I'm going to do our first one here, and I'm going to say, okay, for y equals, what is it, x minus 1? I'm gonna plug in our y coordinate, 1 for y, and I'm gonna plug in 2 for x, since we said that was the x value of the point of intersection. On this side, I can't do anything, we just have 1, but 2 minus 1? That does equal 1. 1 equals 1, that's true. That is true, left side equals right side, so that proves that, okay, for that equation, it works. And then I'm just gonna do the same thing for the second equation, which we said y equals negative 1/2 x plus 2. And I'm doing the same thing where I'm plugging in 1 for y and I'm plugging in 2 for x. Which, okay, I've got here, what even is that? Negative 1/2 times 2? What did we say about the fractions? Really? So 2 times negative 1 is what? Well, 2 times negative 1? Negative 2? Negative 2 divided by 2? Negative 1. Perfect. Which overall, this is still just gonna leave me with 1. So it is true. This is the solution. If we got, for example, 1 is equal to like 2, where it does not add up, left side does not equal right side, then that's not the point of intersection. And we did something wrong in graphing. So that can always be like a way to help you verify if you did the slopes right, because you should see then, it should equal the same. Coolio? Am I good to flip? Yeah? Okay. So you'll see, here's a couple, right? Maybe I do 2A and you do 2B, and we'll try it, okay? So for example, with A, friends, okay, I'm gonna pick my colors.
Why is the first one always so easy?
Would you rather do this one on your own and then we do the next one after it? Okay, you do this one then on your own and then we'll do the one after it, yeah? Yeah, just check your phone before you go. Okay, you try this one. And then someone do it on the iPad. Okay, Jack.
Alright, hey guys, so what we're gonna do is y equals 1 over 1x plus 3.
Okay.
So let's start with that one. So we start at 3, so 1, 2, 3. And then we go up 1 to the right.
Yes.
And then once you have no space, you go the opposite way.
You got it.
Okay, now that one's done.
If you hold it down with the pencil, it would straighten, but okay.
Wait,
Wait,
I have a question.
I can't do it.
Okay.
Okay, and then this one. Oh, pink.
Why are you 4 lines?
I tried to make one, but straight. Y equals. And then 1 over 1 minus 1. X plus 1. Okay, now, guys, we're going to start at 1. Now we're going to go 1 down and then 1 to the right. And then 1 down, 1 to the right, 1 down. And we're going to go the opposite way. Okay. There we go. Yeah, I did. Okay.
Voila, so what's the final answer? What's the point of intersection?
Okay, so the point of interception is 1 and then 2. So 1, 2.
Okay, and then could you check it?
Yeah, I can.
This little bit to see, like, are we sure that it is 1, 2?
Yeah, so what we do is for the left side we go y equals 2 and then plus 1. So then 1 equals 2 plus 1. But that doesn't make sense.
Because I think you put 2 for x instead of 2 for y. 'Cause 2's your y. Which then if you switch those two,
Yeah.
2 is equal to 1 plus 1. That sounds a little bit more.
Yeah, that's correct.
Okay, and then what about the second one? We have to confirm both first.
Okay, so for the second one, does the y equal 2 still? What is the y? Yeah.
The y is still 2, so we'll say 2 equals. And then we've got negative x plus 1. So if x is 1, then that's like saying negative 1.
Yeah, so negative 1, but then it's divided by, oh, it's negative 1.
Because this is negative 1.
Yeah.
This is at negative 1. So negative 1?
Yeah. This is when I get confused with the check.
That's okay. Here. For if you want to erase. This is like saying, okay, if y is equal to negative x plus 1, which I think our POI, Jack wrote 1, 2, but because it's on the negative side, it's negative 1, 2. Right? That's okay. Don't worry. Okay, watch. That's, I'm going to have to bleep that in the YouTube video.
I'm sorry.
Right? Y is 2, x is negative 1, so this is saying 2 is
Wait, are we
equal-
on tape?
Yes, you're being recorded.
Yeah.
It picks up audio.
Wait,
I was talking to it.
Right? If I have a double negative, what's
Positive, so it's 1 plus 1 equals 2.
that? Like that.
Okay, so
Check.
y, oops, wrong color. Y equals,
no, I thought we were like on tape. It's like, because of my guys.
and then go here, and then. Okay, so negative and negative equals a positive, so it's actually 1 plus 1, so that's 2 equals 2, so that's correct.
Thank you, Jack.
Sorry for making you have to believe.
That's okay. Okay.
What are the two little squiggles? Never mind, it's an equal sign.
That's an equal sign, yes. So you're going to notice it's the same process for all of these examples over and over again. So even though your values might change, as long as you're in y equals mx plus b mode, you're going to be fine.
Wait, can you go up?
Yeah?
Do you need a graph in order to find the point of intersection?
For right now, yes. We are going to learn the ways where you don't need to graph to find the point of intersection, because there's 2 algebraic ways we can do it. So we're gonna learn that together, so don't worry. It's okay. Am I okay to swipe?
Can we try the next one?
Yeah, try the next one.
You want me to, or
no, I
you
can
want
do
to?
it.
Can we try it on our own?
I was gonna say, you could take this time. The only thing that I wanted to call to your attention, friends,
Yeah.
James, can you move back to your spot? Thank you.
We're literally
Yeah.
like ahead though.
No, but you're having a conversation, please and thank you. Okay. So the only thing that I want to call to your attention is when it's not in y equals mx plus b mode. So if you notice, if you flip your page, because you've got this page, they're all in y equals mx plus b. So you don't have to do any rearranging. This is the only page where it's not in y equals mx plus b. So the only thing you need to do first is rearrange, and then you can graph. So that's the only little extra step. So even, it's 9:51 now. If you want to, are we good? See, I tried to be nice in the seating plan by keeping friends with friends, but I can do a full jumble up if we can't handle this, right? So, okay, I would like for you to spend the next 30 minutes of class attempting these problems. I said the only ones you'll encounter at the end are ones that are not in y equals mx plus b format. So you will just have to rearrange first and then graph. But it's still the same thing over and over again. Don't complete this. Don't go to this, okay? 1.1b, we're not doing that, okay? So just leave it. That's fine. We're gonna only go up to these graphing examples. You don't have to do the textbook, okay? Just finish the handout. So I'll walk around, I'll help, try it, and then we'll take it up either like tomorrow if we've got like 5 minutes before the class, we can go over it, and I'll post like the answer key to like check your examples. Okay.